All right, we're going to be starting with the first example. This is example 1 from the book. So we're asked to find the indicated real nth roots of A. So that's root singular or roots of A. Now if you look in this one, you've got your n value equals 3 and A equals negative 216. So we're going to start with A first. Now in order to do this, it helps to have a definition here. So if you go to this is page 125 of your journal, you've got two definitions here, two vocab words. Now, it says in your own words, write the meaning of these, but I'm just going to give you the definition so you actually know this. Now, what you've got here is for an integer n that's greater than 1, you've got if b to the n power equals a, then b is an nth root of a. Now I'm going to go ahead and write a little bit for you. So what this means, again, you've got, so for an integer n greater than 1, so what that means, if n is greater than 1, that means that b to the n, so that's written like this, b is your base and n is your exponent. If b to the n equals a, then b is the nth root. So b equals the nth root of a. So that's nth root of a. Okay, what that means is nth root of a. Sorry, it takes a little bit to write this. So again, you're looking at this, if you've got a positive number right here, if b to the n equals a, so if you've got a number that is your exponent of a base, if that equals a, then what you'd say is that value equals the nth root of a. So the way you write an nth root is that just means that n is your index of a. So you can also write that in fraction form. So that would also be a to the 1 over n. Remember, if you write the square root, we learned that that's just 2 as your index. That's also written as a to the 1 over n. So what that means is we're just trying to find the value that would be our base to the n power equals a. So we're just saying b equals the nth root of a. Now you'll see that in a minute when we try to do some examples of these. And you would say the index of the radical, that's just this n value right here. When you have a radical of a number, the index is just this n value that goes in front of our root sign. Now it's important to remember that this is always true. If you have a to an exponent, 1 over that exponent, the n value that is on your denominator is also the index. Okay? So again, I'm going to show you some examples that will make more sense when we do this. But what that means is if you have a number to the exponent and that equals a, then whatever your base is just the nth row or nth root of a. Okay? This is going to make a little more sense when we do some examples. Sorry about that circle. Now, if you look at it right here, you've got a way to calculate this. Now, I want you to keep these core concepts handy when you're doing some examples here. So, you have some ways to figure out when you're trying to find the nth root of a, what that means is if you're trying to find the number that's your exponent to a base and what that number is to equal a, you have some ways. If n is an even integer, then you've got some calculations right here. Okay, if your a value is negative, there's no real roots. If it equals 0, then your nth root is just 0. And if it's greater than 0, you've got 2 real roots. You've got plus or minus whatever your nth root of a is. Okay, and remember it's plus or minus. Now, if n is an odd integer, if it's negative, you've got 1 real nth root. If it's 0, you've got one real nth root. If it's positive, you also have one real nth root. Okay? It's just these are just the nth index of A, the nth index of A. Now, let's go ahead and go back right here and look at our example. So here, we're trying to find the indicated real nth roots of A. So if n equals 3 and A equals negative 216, again, if you go back to our core concepts, here we've got n is an odd integer and A is less than 0. So we know we're going to have one real nth root here, and it's just going to be the nth root of A. Again, n is an odd integer, and we're going to have A is less than 0, so we're going to have one real nth root. So let's go back here right now. So again, it says because n is 3, it's odd, and A is less than 0. Negative 216 has one real cube root. So because negative 6 cubed is negative 216, we can say that negative 6 is our indicated real root. So we know right here that negative 216 is just, so if we take the cube root of negative 216, we get negative 6. So that's how we calculate this. In this case, because n equals 3 and A is negative 216, we just take the cube root. Now again, you're going to be doing some examples, and it's going to start, after some repetition, you'll get this. Now, I clicked ahead right here, but when you're trying to find the real nth root of A, right here, you've got n equals 4 and A equals 81. So if you look over here, n is now an even integer, and 81 is greater than 0. So this is going to have two real nth roots. So here we're just going to take, n is going to be our index of A, and it's just going to be the plus or minus when we do the fourth root of A. So we go back over here, and we do, we have, remember, b to the fourth power equals 81, or plus or minus the fourth root of 81 just gives us plus or minus 3. Now remember, because it's even, we have both the plus or minus value. So again, if you take 3 plus or minus 3 to the fourth power, we're going to get 81. Now again, I don't want you to sit down and just say this is hard or you don't understand. You have some instructions that are very clear right here. When you're trying to do this in your journal on some practice problems, and you are trying to find, you have some problems that are written out like this, find the indicated real nth root, you have an exact process that you're going to go through. You can look at n and see if it's even or odd, and then you can look at A and see if it's less than 0, equal to 0, or greater than 0, and you're going to know exactly how many roots you're supposed to find. Now what that means is when you have your n value and you have your A value, you're basically looking for what number to this power gives us this answer. Okay, that's what finding the root means. Okay, you're looking for what number to this power equals your A value. That's all you're trying to find. This is your nth root right here. You're looking for the base to the nth power that equals A. So here we found that negative 6 to the third power equals negative 216, and here we found that 3 to the fourth power equals 81. So again, we knew that this was n was 4 and 81 was A. So we found that 3 to the fourth power equals 81. So it's really not that difficult right here. Okay, I know some of this definitions maybe make it seem a little complex, but it's really quite simple. If you have any questions, you can go back and pause it and repeat it a little bit. Okay, so right now what I want you to do is work on the extra practice problems 1 through 3 that are in your journal for this section.